Welcome to our exploration of diodes, one of the most fundamental components in electronics. Diodes are everywhere from your smartphone to your home appliances, quietly ensuring that electricity flows in the right direction. In this video, we'll break down what a diode is, why it's so important, and how it works in everyday circuits. Whether you're a beginner or just curious about electronics, understanding diodes is a great first step. Let's start by looking at the basic concept of a diode and why it's considered a one-way street for electric current. Diode is an electronic component that allows current to flow in only one direction. Think of it as a one-way valve for electricity. This unique property makes diodes essential in protecting circuits and controlling the direction of current. Diodes are made from semiconductor materials, most commonly silicon, and are designed with two terminals, the anode and the cathode. When voltage is applied in the correct direction, the diode conducts electricity. If the voltage is reversed, it blocks the current. This simple yet powerful function is the foundation of many electronic devices. Let's take a closer look at how a diode is built. At its core, a diode consists of two regions, the p-type and the n-type semiconductor materials. The p-type region has an abundance of holes, while the n-type region is rich in electrons. These two regions are joined together to form a p-n junction. The anode is connected to the p-type side and the cathode to the n-type side. This structure is what gives the diode its unique ability to control the flow of current. The simplicity of its construction belies its importance in electronic circuits. So how does a diode actually work? When you apply a positive voltage to the anode and a negative voltage to the cathode, the diode is said to be forward biased. In this state, current flows freely through the diode. However, if you reverse the voltage, the diode becomes reverse biased and blocks the current. This behavior is crucial for protecting sensitive components and ensuring that electricity only flows where it's supposed to. The ability to control current flow with such precision is what makes diodes indispensable in electronics. Circuit diagrams: diodes are represented by a simple symbol, a triangle pointing towards a line. The triangle represents the direction of current flow from the anode to the cathode, while the line indicates the barrier that blocks current in the opposite direction. This symbol is universally recognized and helps engineers quickly identify diodes in complex circuit schematics. Understanding this symbol is key to reading and designing electronic circuits. There are several types of diodes, each designed for specific applications. The most common is the standard silicon diode, used for general rectification. Other types include Zener diodes, which regulate voltage, and light-emitting diodes, LEDs, which emit light when current passes through them. Schottky diodes are known for their fast switching speeds, while photodiodes are sensitive to light. Each type of diode has unique characteristics that make it suitable for different tasks in electronics. Rectifier diodes are perhaps the most widely used type of diode. Their main job is to convert alternating current AC into direct current DC, a process known as rectification. This is essential in power supplies for electronic devices where a steady DC voltage is needed. Rectifier diodes are robust and can handle high currents, making them ideal for use in chargers, adapters, and many household appliances. Zener diodes are special because they can conduct electricity in the reverse direction when a certain voltage is reached. This property makes them perfect for voltage regulation. In power circuits, Zener diodes help maintain a stable voltage, protecting sensitive components from voltage spikes. They are commonly found in voltage regulator circuits and are crucial for the safe operation of many electronic devices. Light-emitting diodes, or LEDs, are a special type of diode that emits light when current flows through them. LEDs are incredibly efficient and are used in everything from indicator lights to large display screens. Their low power consumption and long lifespan have made them the go-to choice for modern lighting solutions. LEDs come in various colors and sizes, making them versatile for many applications. Schottky diodes are known for their fast switching speeds and low forward voltage drop. This makes them ideal for high-frequency applications, such as radio frequency (RF) circuits and power rectifiers and switching power supplies. Their efficiency and speed help reduce energy loss and improve the performance of electronic devices, especially where quick response times are needed. Photodiodes are designed to detect light. When light strikes the photodiode, it generates a small current. This property is used in a variety of applications such as light sensors, solar cells, and optical communication systems. Photodiodes are sensitive and can detect even low levels of light, making them essential for devices that rely on light detection and measurement. Diodes are used in countless applications. They're found in power supplies, radios, televisions, computers, and even in your car. Their ability to control the direction of current makes them invaluable for protecting circuits, converting AC to DC, and even generating light. Whether it's for signal processing, voltage regulation, or light emission, diodes play a critical role in modern technology. In power supplies, diodes are used to convert AC from the wall outlet into the DC needed by electronic devices. This process, called rectification, is essential for charging batteries, powering computers, and running household electronics. Without diodes, our devices wouldn't be able to safely use the electricity provided by the power grid. Diodes are also used to protect circuits from voltage spikes and reverse polarity. For example, in automotive electronics, diodes prevent damage when a battery is connected the wrong way. They also protect sensitive components from sudden surges in voltage, ensuring the longevity and reliability of electronic devices. Diodes are used in radios and communication devices to demodulate signals. This means they help extract audio or data from high-frequency carrier waves. By allowing only certain parts of the signal to pass, diodes enable clear and accurate transmission of information, making them vital in the world of communication technology. Zener diodes are commonly used for voltage regulation. They maintain a constant output voltage even when the input voltage fluctuates. This is crucial for sensitive electronics that require stable power. Voltage regulation ensures that devices operate safely and efficiently, preventing damage from voltage variations. Photodiodes are used in light detection and sensing applications. They are found in devices like smoke detectors, remote controls, and solar panels. By converting light into electrical signals, photodiodes enable a wide range of automated and energy harvesting technologies. LEDs have revolutionized lighting technology. They are used in everything from flashlights to streetlights, offering bright, energy-efficient illumination. LEDs last much longer than traditional bulbs and consume less power, making them an environmentally friendly choice for lighting solutions. Diodes are used in logic circuits to perform simple logical operations. By controlling the flow of current, diodes can create and, or, and not gates, which are the building blocks of digital electronics. These circuits are found in computers, calculators, and many other digital devices. In switching circuits, diodes act as fast electronic switches. They can quickly turn current on or off, making them essential in power management and signal processing. Their speed and reliability are crucial for modern electronics that require rapid switching capabilities. Reverse polarity protection is another important application of diodes. By placing a diode in series with a power supply, devices are protected from damage if the power is connected backwards. This simple solution saves countless devices from accidental destruction. Flyback diodes are used in circuits with inductive loads like motors and relays. When the current is suddenly switched off, the diode provides a path for the current, preventing voltage spikes that could damage other components. This is crucial for the safe operation of many electromechanical systems. Diodes are used in clipping and clamping circuits to shape voltage waveforms. Clipping circuits remove parts of a signal above or below certain levels, while clamping circuits shift the entire signal up or down. These techniques are important in audio processing and signal conditioning. Voltage multiplier circuits use diodes to increase the voltage from a power source. These circuits are used in devices that require higher voltages than what's available from the power supply, such as cathode ray tubes and some types of sensors. In radio frequency (RF) circuits, diodes are used as mixers and detectors. They help combine or extract signals at different frequencies, enabling the reception and processing of radio signals. This application is vital for communication devices like radios and televisions. Some diodes are used as temperature sensors. The voltage across a diode changes with temperature, allowing it to be used for temperature measurement and compensation in electronic circuits. This property is useful in many industrial and consumer applications. Solar cells are a type of diode that converts sunlight into electricity. When light hits the cell, it generates a current, providing clean and renewable energy. Solar cells are used in everything from calculators to large solar power plants, helping to power our world sustainably. In choosing a diode for a circuit, several parameters must be considered. These include the maximum current it can handle, the maximum reverse voltage it can withstand, and its forward voltage drop. Understanding these parameters ensures that the diode will function correctly and reliably in its intended application. Forward voltage drop is the minimum voltage required for a diode to conduct current. For silicon diodes, this is typically around 0.7 volts, while for Schottky diodes it's lower, around 0.2 to 0.4 volts. This characteristic affects the efficiency and performance of electronic circuits. Reverse breakdown voltage is the maximum voltage a diode can withstand in the reverse direction before it starts to conduct. Exceeding this voltage can damage the diode. Zener diodes are designed to operate in this region, but most other diodes are not. The current rating of a diode indicates the maximum current it can safely carry. Exceeding this rating can cause the diode to overheat and fail. It's important to choose a diode with a current rating that matches the needs of your circuit. Power dissipation refers to the amount of power a diode can safely convert to heat. If a diode dissipates too much power, it can overheat and become damaged. Proper heat management is essential, especially in high-power applications. Switching speed is the time it takes for a diode to turn on or off. Fast switching is important in digital and high-frequency circuits. Schottky diodes are known for their rapid switching capabilities, making them ideal for these applications. Temperature stability is a key consideration for diodes used in harsh environments. Some diodes are designed to operate reliably over a wide range of temperatures, ensuring consistent performance in automotive, industrial, and outdoor applications. Diodes come in various shapes and sizes, from tiny surface mount devices to larger through-hole packages. The choice of package depends on the application, available space, and cooling requirements. Proper mounting ensures reliable operation and heat dissipation. Testing a diode is straightforward using a multimeter. By measuring the voltage drop in the forward and reverse directions, you can determine if the diode is functioning correctly. A good diode will show a voltage drop in one direction and block current in the other. Diodes can fail due to excessive current, voltage, or heat. Common failures include short circuits where the diode conducts in both directions and open circuits where it doesn't conduct at all. Proper circuit design and component selection help prevent these issues. If a diode fails, it's important to replace it with one that matches the original specifications. This ensures the circuit will function as intended. Always check the current, voltage, and package type before installing a new diode. When handling diodes, avoid static electricity and excessive heat. Use proper tools and techniques to prevent damage during installation. Following safe handling practices ensures the longevity and reliability of your electronic projects. Diode technology continues to evolve, with new materials and designs improving efficiency and performance. Innovations like organic LEDs, OLEDs, and silicon carbide diodes are opening up new possibilities in lighting, power electronics, and renewable energy. The future looks bright for this essential component. You might not see them, but diodes are everywhere in daily life. From the charger that powers your phone to the LED lights in your home, diodes work behind the scenes to make modern technology possible. Their reliability and versatility have made them a cornerstone of electronic design. Let's recap what we've learned about diodes. They are essential components that control the direction of current, protect circuits, and enable a wide range of technologies. From rectification to light emission, diodes are at the heart of modern electronics. Understanding how they work and where they're used is fundamental for anyone interested in technology. Diodes may seem simple, but their impact is huge. They make our devices safer, more efficient, and more reliable. As technology advances, diodes will continue to play a vital role in shaping the future of electronics and energy. If you're interested in learning more about diodes, consider exploring topics like semiconductor physics, circuit design, and advanced diode applications. There's a whole world of electronics waiting to be discovered, and understanding diodes is just the beginning. Thank you for joining us on this journey through the concept of diodes. We've covered their structure, function, types, and applications, highlighting just how essential they are in our everyday lives. As you continue exploring electronics, remember that even the simplest components can have a profound impact on technology.